Hello everyone, welcome to my YouTube channel. I am Naveen Mishra and I'll continue teaching how to write or work in C language. In my previous videos, I have told you about recursion, nesting, inner functions and all the other topics related to C language. I'll continue with another important topic, that is storage classes. Before I continue, I would like you guys to please subscribe and share my YouTube videos as much as possible. Okay, thanks for that, and let's start with the new topic, storage classes. So what are storage classes? When we declare a variable or initialize a variable in C language or in C++ language or in Java language, along with the data type as well as the memory size of variable, there are many other things that you must want to know that what is happening with that variable. For example, number one, initial value. Let's say you have declared this variable int a and you don't put any value inside the a. So your a does not have any value initially given by you. And if you print this value, what should be the value printed to you? Sometimes it may produce 0, sometimes it may produce any value, that is garbage. Most of the time Turbo C produces you garbage value, whereas Dave C most of the times will produce you a 0 value. But this is not sure, so you will never know what is the initial value. Second, storage area. Now the programmers must know that whatever program you write or whatever software you run, they are executed in the computer's main memory, that is RAM. Now these variables take bytes like 2 bytes, 4 bytes and 8 bytes. These 8 bytes or 4 bytes are taken either from RAM or from CPU's own memory, that is called registers. Here CPU I mean processor. The processors like i3, i5, 8085, 8086, they have their own memory which is called registers. Registers are nothing but they provide a faster access to the data to the microprocessor. So microprocessors can access the data quickly if the data is stored inside the registers. So you can decide whether you want to store the variable in register or in RAM. The third thing is scope of the variable and lifetime of the variable. Scope, to understand the scope, think about any natural language that we guys speak, like Spanish. Let's say Spanish, if a person knows the Spanish language, the person can only communicate within the Spain or within the region where this language is most usually spoke by the people. But what if the person goes to some other country? Will this language be accepted? So similar to that, scope. For example, Hindi language is acceptable in, let's say, India, but outside other countries like Europe or USA, the Hindi language won't be understood by other persons. So this is the scope, that in Hindi language has a scope of national, that is within India. Okay, so similar to that, scope and lifetime also matters. To understand the same concept in programming, let's say you have a function void add and you have a variable declared int a here. You can print this value definitely here, that within the function this value will work. But what will happen if I try to print the same value in the main function? It may or may not work, but definitely it will not work, because this variable is only valid within this area and not outside this area. To understand these four concepts, to explain for these concepts, the topic comes storage class. So what is a storage class? Storage classes are used to define four purposes. What is the initial value of a variable? What is the scope of variable? What is the lifetime of the variable? Lifetime means how long the memory allotted to the variable stays with the variable. That after executing the program, whether the variable value will be deleted or not. Okay, so this is the lifetime. Initial value, lifetime, scope and storage area. Four things are justified by this storage class. Okay, so these are used to know about the storage area, like these things. So there are four storage classes: auto, local; extern, global, which is also known as global; and auto, which is also known as local or internal; then register and static. All these are the keywords, so make sure these are always written in lowercase. So extern should be written in smaller letters, that is E, and A is also in smaller letters or lowercase. Okay, till now, whatever programs we are writing, we are not defining these storage classes. Then by default the compiler will consider all the variables auto or local variables. Okay, now let's start with these four variables. First of all, auto variable or local variable. A variable defined inside the function is by default an auto variable. Why it is called auto? As it is automatically created when the compiler enters the function and automatically deleted when the compiler exits the functions. These are also called internal variables as they are internal to the function in which they are defined. Okay, and they cannot be accessed outside the function. So those four parameters like initial value, scope, lifetime and storage area, the values of auto variables are initial value garbage. Garbage means you cannot expect what kind of value will be printed. Like if you declare a variable int a and without giving it any value you try to print the value, then you do not know what kind of value it can produce. Then scope and lifetime, that is within the function. As long as the function is executing, your variables will be accessible, will have the memory usage. But as soon as you move out of that functions, these lifetime and scope will be deleted, that is variable will be destroyed. So they are defined in the memory RAM. Okay, here you go. Like this int a variable is a auto variable. I have not written here auto, but by default it is auto. So this variable can be accessed within this add function, like from 2 to 5th line within that, but cannot be accessed outside the function. Okay, so these are the auto variables or internal variables. Now if I print the value here, then it will definitely be printed 10, and if I print the value here, then it will generate a compile time error message here. Okay, so these are the automatic variables that we were doing in all the programs before this topic. Now let's talk about the global variable or external variable. What if you want to use a variable throughout your program? Such variables can be declared global. A global variable retains its value throughout the program. They are also called external variables. Their scope and lifetime are as it is. Their initial value is by default set to 0. So if you forgot to give a value to your variable like int a and you print the value straight away, then it will print the 0 value. Scope and lifetime, within the program you can use it, call them anywhere, you can use them anywhere, and they are stored inside your computer's memory RAM. There you go. Like this variable int a, this is not defined inside any function void add or main, so this is definitely a global variable. Now this value can be accessed here in the main function, and the same value can be accessed here in the add function. So this a variable can be used anywhere within your program, either in main or in add function. Okay, so these are the global variables. Both will work properly and they will print the message 10. Now register. Now as I have explained you earlier that registers are processor's own memory and they provide the faster access to the data of the variables. But whenever you declare a register variable, this is not sure that they will always be stored in the CPU register. Based on your hardware implementation, based on your storage access, based on your memory access, they might or might not be stored in the CPU registers. So most of the time, yes, they will be stored in the CPU register, but may or may not. So make sure that they may not. The main concept of registers is to have the faster access. They can only be local variables. You cannot have a register variable global. Okay, so they have only local variables. So definitely their scope, lifetime and initial value are same as the local variable. So there you go. Their initial value is garbage. Scope and lifetime is within the function, but their storage area is CPU registers. To have the faster access, that's it, nothing else. This is the way you can declare your register variable. Like register in text, you will use the keyword register in front of your variable declaration and you will have a register variable. Okay, now let's talk about the static data type. So this is a static data type. Within the function, you want to use a variable that can retain its value throughout the program. This is only possible if you declare your variable static. A static variable can retain its value throughout the program and they are automatically initialized to 0. So if you forgot to give a value to your static variable, they are automatically set to 0. And they can be local as well as global. Okay, so what is their initial value? As I have explained you, 0. Scope, based on whether you are declaring a local variable or global variable, and same lifetime throughout the program. Now lifetime, whether your variable is local or global, they can be used or accessed throughout the program. They can retain their value throughout the program. And their storage area is RAM. So there you go. This is my static variable. This is a global variable as it is declared outside the function, and this static int b is a local variable that is defined inside the function. Both variables can be used and assessed. Okay, so these are my static variables. Static variables are very useful and used in management programs where you need a counter that is incremented by 1 to represent the total number of persons, the total number of records within the program. So static variable can do this for you, that is generating account numbers, okay, or generating roll numbers for a student, or generating employee IDs for employees. This can be done using a static variable. I'll show you how you can do this. So I'll write a program here, hash include stdio.h. I have declared a variable static int account number equals to 101, and I have used a method create account int p account equals to acc number, then printf your account number is %d comma p account, and I will increment my account number. Okay, so let's say void main, and I'll call this function multiple times. So create account 1, create account 2, create account 3. In this void to int, I'll save test static, and I'll compile my file, and there you go, your account number is automatically incremented by 1, that is 1001, 2, 3. So if you are creating a program related to banking, you can generate your account numbers using your static variables. So static variables are very useful in these purposes. Now let's try to understand what is the difference between static and a local variable. So difference between static and auto. So let's say I have a static variable here, and I just print its value in the static variable p account, and I'll call this function 2 times. Let's see what happens. I have to increment the value as well. Uh, Wait a second. There you go. Your account number is set to 0. Now, what if I increment your account number value by 1? So your first account number is 0, your second is 1, and if I call another, then you will have a value number 3. So what is happening here is that once you enter in the function, your variable is declared and allotted memory. You assess this value, you increment this value, and when you come out of this function, your value is not deleted. Your value stays, and next time you call the function, the same value is assessed, printed, incremented, and then again came back to main function. Your value is not destroyed, and so on. But what if I do not use a static variable here? Compile and run. Just a second. There's a problem. I don't know why they are producing 0, 1, 2 values. Might be they might be incrementing the value in the same way, but generally their value is destroyed. There you go. It is by default set to 0, 0, and 0. Okay, and okay. So in Dave CPP, I don't know why they are working in the same way. Let me try it in the Turbo C. Let's see if it works. Let me try the program here. Declare a static variable here and let's see if it does the same task. And I'll call this function multiple times. And I have to use the void variable here. Let's run this file and you see there this is a garbage value. You do not know what is the value here. Let me use a static variable here. And you see here your values are 0 and 1. So static difference between static and a normal variable is clearly available in Turbo C but not in Day-12. I'll get back to you guys about this in the next video. Okay, so that's enough from my side from this video. Thank you very much for watching my video. Keep on subscribing and sharing my YouTube channel. Thank you very much. See you in the next video. Cheers.